today's session, I would like to guys help for the topics. So performance-based design and analysis for the building structures. So let's get started. For the details, today's content, I will explain following these contents from what is performance-based design, and but also I will show the various project applications. In the community SEAOC vision in the report, they mentioned firstly seismic performance with 4 types factors, as you can see. There was a starting point of performance-based design. After that, the idea has been developed in ATC 40 and FEMA type and ASCE standard. The main purpose of seismic design is safety. Firstly, engineers choose the performance objective. So we have to choose the 4 types of seismic performance level depending on damage about structures. This is the standard procedure of performance-based design process. First of all, determine the performance objective and perform dynamic analysis for assessment of performance capacity. If you get results not good, you have to revise the design or set objective again. The performance-based design today can be explained 2 ways. Firstly, utilization in existing structures. Normally, engineers use the standard ASC 41 and 13, or FEMA, the latest FEMA type. Second one is for new structures. Engineers use TBI standard in practical projects. So for the design, engineer combines ASCE standard with this standard. Then let's think about what we must focus on performance-based design. Just following other countries like American or Japan, where that is advanced design code than current standard. I think the clear answer about those questions of current standard has a little bit some risk about their assumption. From analysis and design perspective, there are some differences. Here, the meaning of 2-level design, strength design and serviceability design. And traditional approach is expensive design work. About complicating multi-degree of freedom structure. But a performance design approach can assess clearly about structure system, which has a dissipation of energy or ductility capacity. This graph can explain VE R1 value is actual seismic load, but engineer considers ductility capacity dividing with R factor. So we design R factor until now, and then design a rebar arrangement to some members considering seismic details. During design work, R factor and seismic load are assumptions. That is point for ineffective and uneconomical method than performance-based design based on actual loads. Difference between linear and non-linear is whether is constant or not. So difference between elastic and inelastic is the value return or non-return along the previous line or not. From now on, I will explain nonlinear analysis in the chapter 3. Then what is a difference between ASCE and TBI standard? As you can see, ASCE 41 doing a linear analysis first and check the results depending on elements or a system. But TBI, a tall building design guideline, there is only one way using dynamic analysis. You guys already know about analysis and analysis. But some of us, I can explain about the basic concept of analysis and analysis. One point direction. Analysis can process continue until the design. That is why performance criteria. The restaurant is slowly increased and the sequence of effects building and the failure of a component will be reversed. So Australian community is modeled by starting the potential condition. Variation of forces and maximum response. on the previous page of the first page. Methods are distinguished study and dynamic depending on the time. And depending on the period, it can be distinguished linear and nonlinear. As you can see, fictional analysis is nonlinear static analysis, and time story analysis can analyze the whole time linear and what about the
tengah-tengahnya aja.
Especially in seismic control device analysis is used for performance-based design in practical projects. When engineers analyze nonlinear analysis, they have to model including properties each member. So in this picture, Midas Gen offer hinge properties and a fiber model. In the hinge model, there are two types which are lumped and distribute hinge. And fiber model, engineers define depending on material properties for concrete cell and steel cell. But also engineers can use beam column, wall, truss, generating for nonlinear analysis. For high status model, there are various types from material nonlinearity. This is inelastic material model and hysteresis model in Midas Gen. The most usage model are Mender type model, Park model, bilinear model, and FEMA model. Of course, a user can define manually the model which is considered degree. In chapter 4, I explain about application examples for the seismic performance design and existing buildings. The first case is a seismic assessment about educational elementary school building in Korea. Currently in Korea, seismic assessment about school building is mandatory. Based on ASCE 4113, engineers modify seismic parameters as Korean condition. As same with performance-based design, firstly is set up the performance objective. Then different point is that engineer replace masonry wall model to truss model. So firstly, doing preliminary evaluation, and then first detailing evaluation, and lastly, second detailing evaluation. This is a general outline of model. Along Y direction, there are shear wall and basically braced frame systems. As I mentioned before, masonry were remodeled as truss element. This structure was built 40 years ago, so that is not considered about seismic design. So we require performance analysis and design, and the performance objective is life safety. We have started to analyze the seismic performance assessment because of the earthquake in 2018. At that time, the Richter scale was only 5, but it had a huge effect. So especially a school was built with masonry work. So because of that reason, those types of building had a huge effect. Since the accident, seismic accident, engineers analyze the seismic performance assessment all about in Korea. You can check the most critical crack in the picture. A joint crack and a column masonry were following those pictures. Especially a diagonal crack or shear failure of column is really important because that action can affect a building collapse. In Midas Gen, a user can define material property of masonry work for seismic performance assessment. Masonry work is separated two types of as a field work or waste work, and a user can assign those depending on material properties. The elastic modulus of masonry work is assigned using the user define, but also put in the size and assign the data as a scale factor. As you can see, the structure is consists of waste work in the picture. Waste work is the main reason to affect shear failure of column. So we modeled as a following previous slide, as effective buckling length is short than before. Waste work is more weak about shear failure more than field masonry work. Including masonry work, user can define effective stiffness, which is considered crack section about beam, column, or elements at the same time. This value is from data from the ASC 41. Following picture, we can check the difference between column 1 and column 2. Considering the hinge properties about those columns, only one property is shown, column 1. But column 2 is divided into two types of hinge properties. So depending on that, member assignments is very important because the result of pushover analysis will be able to different engineer must be careful about these issues. The procedure of seismic assessment is 3 steps. First one is a preliminary assessment. only a hand calculation using Excel sheet. And the second one is a detailed evaluation, step 1. Doing analysis as a seismic design, inputting response spectrum load case or equivalent static load case. But in this step, there is a different thing regarding seismic design and assigning M factor for each element with keeping R factor. And last, step 2, evaluation using pushover analysis. User assess performance elements, but also structural full system like story drift and acceptance criteria. These seismic assessment features are already upgraded in Midas Gen. And this data is ASDE plus hinge model, which was considered force and deformation. And right side, next one is the result from pushover analysis along X direction. The performance point was found at 61 step. This feature offers a table based on parameters, results for each element and calculation. We can check easily the results about final elements and for each floor's performance results. In fact, before this function was developed, engineers spent their more time about 4 weeks to assessment. But now they can report the results within only 1 week or 2 weeks. And the second application is apartment building. Korea is not much big, so the residential building, which is at least 15 floors, take up in structure market. So about those residential building is also required for performance-based design. In Korea, almost residential building consists of shear wall only. So this case, the height is like this, and the thickness of wall is 300 millimeter. In the standard, there are 2 levels to design performance results. First one is a service level elevation. You can check the enough results about DCR. DCR means the demand capacity ratio of bending and shear. About this structure, we did time history analysis using 7 types of practical earthquake data. Maximum considered earthquake, about each case of we have to do performance-based design. And this is the results of a story drift along X and Y direction. We can check the different maximum story drift depending on X and Y direction. And this graph shows the shear forces for each floor, we can check the x direction of the bottom shear forces on the first floor. 2 times more than y direction. This graph is plot about compressive strain on the first floor. The blue point for each floor. The limit strain is lower than 2%. So that is safe. In this slide, the capacity of about floor shear force is not satisfied overall. So we need to review the design reinforcement. This residential building is one of the application using performance-based design. We saw the assessments and the results that serviceability and performance design in a residential building. Third one is Grand Tower in Los Angeles. This is a model overview. This model is high-rise for high-rise building. As same with second application, it is nonlinear dynamic analysis using 11 types of seismic wave based on SLE and M.Sc parameter. The arrangement of outrigger was designed, as you can see. The result is different depending on the arrangements of opening. So we can check the different effects about drift value depending on opening area. That means on the applicability about opening is really important in this model. Following the graph, we can see the interesting results about 2 points. Firstly, the tendency is smaller in base shear about response spectrum load case in SLE level than a base shear in design code. And secondly, a base shear value is smaller than nonlinear time history analysis than a response spectrum analysis, same damping in M.Sc level. In the M.Sc level, the permission of the story drift value is 3%. So they were satisfied with that level. And in some floors, it shows a rebar tensile yield and about compressive strain of RC wall member is satisfied with in acceptable level. And plastic rotation also some floors are satisfied, but other floors are not satisfied with criteria. And lastly, fourth model is about shear wall apartments comparison verification example. From now on, I would like to share the information that is comparison between the Midas Gen program and performance ready program about this model. I will show more details in each slide. That is conception of model. The thickness of word is 200 millimeter. First of all, we have to same with mass property. So I compared the mass data about the structure to prove the same condition each software. But also about fundamental period is also important. So I compared as those as well. There's a little bit small gap, but it will not significantly affect of the results of nonlinear analysis. The model about reinforcement concrete and rebar inelastic was defined through linear and bilinear. For wall elements, I assigned 5 models and rebar arrangements as one column array in both the software. The blue box shows the setting about integral points of freedom. But in the P program, I couldn't set up nonlinear properties about out of plane. I analyzed the model using 2 types of analysis. First one is pushover analysis. The total load steps are 50, and when the displacement reach to like this, maximum displacement like this, the program will finish the analysis. This graph, the results about base shear and displacement about pushover analysis. We can check both results are almost same. Moment curvature graph is almost the same. The actual strain value is almost similar with each program. And the second one is nonlinear time history analysis. In that case, I use a direct integration method. In case of damping, I consider the 5% as a model method. Of course, this compared result is similar with both programs. Base shear and roof displacements and moment curvature. Other wall member moment curvature are similar with both programs. And axial strain and W23 member moment. So in conclusion, I would like to share my opinion and about performance-based design and nonlinear analysis. I think we should be satisfied firstly in linear analysis. We will trust the results in nonlinear analysis. The nonlinear analysis results should be changed depending on input data. So engineers have to review all results but also it is emphasized peer review in various standards. So generally, we need to review with various methods and cross-check with other engineers. So performance-based design guideline is really practical, but engineers' decision is the most important. Not only performance-based design, but also seismic assessments about existing building is really important. There are many types of new building, but more practical point is maintain existing building. This movement is currently done USA, and Korea, Japan, China, and various countries. In the near future, performance-based design will replace design work for all types of buildings. So thank you so much for hearing my presentation, and please give me questions about my presentation.